students, welcome back with new lesson of physics for grade 9. This lesson we will continue speaking about thermal physics. We have studied before kinetic molecular theory and we use it to improve the different behavior of solid, liquid and gas, and also we use it to prove the gases law, Boyle's law, Charles' law, and combination between three law, which we study three variables: pressure, temperature, and volume. Now we'll continue with thermal physics. We'll study internal energy, energy of the moving particles that compose matter. We have know that all matter consists of tiny particles or molecules. Today's key terms and ideas: thermal energy, kinetic theory, heat, thermal equilibrium and heat transfer, kinetic theory as it relates to expansions and contractions, hot vs cold. Physics and particles. Particles is a general term used to describe molecules, atoms, and subatomic particles. At first, we will study temperature. The higher the temperatures of substances, the faster the motion of its molecules. The first postulates for molecular theory. This is also referred to the kinetic theory. All matter is made of atoms and molecules that are continuously moving. The higher the temperature, the faster the particles move. Gives the same temperature, the heavier particles move slower than lighter particles. This diagram shows the different molecules moving and arrangement in different substances at a different temperature: solid, liquid and gas. This is solid state, liquid state and gas state. Matter is a changing state from solid to liquid by melting, from liquid to gas by evaporation, and from gas to liquid by condensation, from liquid to solid by freezing. Particle speed is increasing when changing from solid to liquid, increasing average kinetic energy, increasing temperature. Temperatures and kinetic energy. Temperatures is related to the average kinetic energy of the atoms and the molecules in substances. The faster the molecules move, the temperatures and the is greater. So greater the temperatures and the greater the average kinetic energy and the greater particle speed. Heat. Heat is the quantity of thermal energy transferred. Heat always flow from substances with higher temperatures to substances with a lower temperature. Heat flows only when there is a difference in temperature. Heat units are calories or joule. Just as waters will not flow uphill by itself regardless of the relative amount of water the earth reservoirs, heat will not flow from cooler substances into hotter substances by itself. It means the waters can't flow from down to up, but just flow from up to down. Okay, so the energy can't transfer from cold place to hot place. It moves from hot place to cold place, and this is called entropy. Flow from higher to lower energy state. What causes heat to flow? A difference in temperature? Yes, between objects in thermal contact. When we have two objects contact or thermally contact, so the temperature will transfer from hot object to cold object to have stable or equilibrium temperature. Thermal equilibrium. What happens when a warmer substance comes in contact with a cooler substance? Heat flow between two objects of different temperatures until they have the same temperature. The loss of thermal energy from the warmer object equals the gain of thermal energy for the cooler object. This is right if the two objects are isolated from the surrounding. If they didn't isolate it, so some of heat will escape to the surrounding. So this is right only if the two objects are isolated. Most forms of matter, solid, liquid, and gases expand when they are heated and contract when they are cold. This is thermal expansion. When we heat up any object, any matter, it will expand. But all matters have the same rate of expansion with heat up? No. Gases more expansion than liquid than solid. When the temperatures of a substance is increased, its molecules faster and normally tend to move farther apart. This results in an expansion of the substances. Gases generally expand or contract much more than liquids. Liquids generally expand or contract more than solid. How does thermometers work? The kinetic theory P used to explain expansion and contraction of matter when the temperatures of the materials change. As the temperature rises, heat is transferred from the surrounding to P liquid inside the thermometer, and the molecules that compose the liquid vibrate faster. This causes the liquid to expand and rise. So, if I ask you about how we can measure the temperatures of the material, we use, yes, the thermal expansion properties to measure the temperatures of the material. The liquid in the thermometer stops rising or falling when thermal equilibrium is reached. No more heat flow. It means we have a liquid inside the thermometer. This liquid, when contact thermally with the object, the energy will start, or the heat will start to transfer from the object to the liquid inside the thermometer. The particles of thermometer will start to move faster and expand. This expansion is referred to the temperatures of the object. Air temperatures equal liquid temperatures. Specific heat capacity. Do copper, clay, and water have the same chemical composition? No, it's different. They are different. They have different composition. So, no, copper is composed of Cu atoms and water is composed of H2O molecules. Clay is complex silicate. The difference in chemical compositions influence how copper, clay, and water respond when heat is transferred. So, the specific heat capacity of substances is a quantity of heat required to raise 1 gram of a substance by 1 degree Celsius. It means not all matters have the same heat capacity because it's property of the matter, because of all matter didn't have the same composition. Specific heat capacity. A substance with high specific heat capacity can absorb a large quantity of heat before it will rise in temperatures. What has a high specific heat capacity? A substance with a low specific heat requires relatively to raise its temperatures. Copper has a low specific heat capacity. So if we have 1 kilogram or 1 gram of copper, if we want to raise its temperature by 3 degree or 4 degree, we will use little heat energy. But if we need to raise up to 3 gram or 4 gram of water 2 or 3 degree, it will need more heat or more heat energy. Specific heat capacity for different materials. This is table. Materials, water, it's need about 4.186 joule per gram or calorie per gram. This is used, we need about 4.186 joule to raise 1 gram of water only 1 degree, and aluminum about 0.9, and clay 1.4, and so on. So we will see water is more specific heat capacity. This is highest, this is lowest. Steel just need 0.448 joule to raise up 1 gram of steel or iron 1 degree. Think, which has a higher specific heat capacity, water or sand? Explain. Yes, water has a greater heat capacity than sand. Water is much slower to warm in the hot sun and slower to cool at night. Sand's low heat capacity show by how quickly it warms in the morning and how quickly it cools at night, affects local climate. So if we go out on the beach, the sand, it will warm faster than water. You can't move on the sand, but it's easy to move on the water because of the specific heat capacity of the water is high and the specific capacity of the sand is low. So after the sun rise, the sand on the beach will rise up its temperatures faster than the water. Specific heat capacity also, a gram of water requires 1 calorie of energy to raise the temperature 1 Celsius. It takes all about 1/8 as much energy to raise the temperatures of a gram of iron by the same amount. The capacity of substances to store heat depends on its chemical composition. If you added 1 calorie, 4.18 joules of heat to 1 gram of water, you will raise its temperatures by 1 Celsius degree. What is the difference between substance with a high specific heat and low specific heat capacity? Substances with low specific heat capacity, like metal, need very little heat to raise temperature. Good conductors, not good absorbers, don't hold into heat well. Substances with high specific heat need a large quantity of heat to raise temperatures. Poor conductors, good absorbers, store and hold into heat well. So metals is good conductor for energy and electricity also, but it has low specific heat capacity and didn't hold heat inside it well. But the materials which has high specific heat capacity, it's poor conductors but good absorber, store and hold into heat well. How does the specific heat of water help to moderate climate? During the summer, surrounding air is cooled by the water and keeps the coast cooler than than the intercontinental locations. During the winter, the surrounding air is warmed by the water and keeps the coast warmer than the intercontinental locations because water has high specific capacity. The property of water to resist changes in temperatures improves the climate in many places. Water has a high specific capacity and is transparent, so it takes more energy to heat up than land does. It means at the same time, if we measure the temperatures on the sand, it will be 25 degree, and in water 20 degree. Why? Because water has high specific capacity than the land. In which three ways can the thermal energy or heat of substances be transferred? The big idea: heat can be transferred by conduction, convection, and radiation. We have three ways. But conduction's collisions between particles transfer in thermal energy without any overall transfer of matter. Just transfer energy, not matter. Heat from the flame. If we have, this is a flame and this is strip of metal. The flame causes atoms and free electrons in the end of the metals to move faster and jostle against others. The energy of vibrating atoms increases along the length of the rule. So we use kinetic molecular theory to improve or to describe the behavior of the conduction. This is flame heat up this part of the metal, so the molecules or atoms and free electrons will start to moving faster and go to the cold region, so the heat will start to move from this part to the other part. The second way for heat transfer is convection. In convection, heat is transferred by movement of the hotter substances from one place to another. Convection occurs in all fluids. Convection fluids, it means, we said it before, fluid, gases, and liquid. Convection currents transfer heat in air. Convection current transfer heat in air like this. This is air. This is arrows represent the convection current moving from down to up. Convection current transfer heat in air. Convection current transfer heat in fluid, in liquid. When fluid particles at the bottom of the pan begin to vibrate faster, they expand and decrease in density, making the hotter fluids move more oil. It means this is a contact surface with heat, so the particles in the bottom will be more hotter than the particle on the surface, so this particle will start to move faster and make convection current go up, and cold particles will go down, and if it hotted, it will be go up. Why the hotted particles go up? Because of its moving. It means move faster, it means it will be expand, so its density will be less, so less dense waters will go up and more dense liquids will go down. This is make convection current. The third way for heat transfer is radiation. In radiation, the heat is transmitted in the form of radiant energy or electromagnetic wave. Most of the heat from the fireplace goes up by chimney by convection. The heat that warms up comes to us by radiation. It means this fireplace, the heat come to this man by radiations, but the heat go up from the chimney by convection. This is the gas, so the heat transfer inside the gas by convection. Radiation is caused by moving electrons or charged particles in matter. The faster the particles move, the higher the frequency of the electromagnetic radiation. Radio waves send signal through the air. You feel infrared waves as heat. A visible form of radiant energy is light wave. Thank you. Goodbye with the new lesson on physics grade 9.